Hello students, in our last lecture we studied till xt graph, that is position time graph for acceleration, and we have studied that if the position time graph is straight line, then in that case velocity is constant, means velocity do not change, and if velocity do not change, then that means there is no acceleration, means acceleration is zero. And if the position time graph is downward curve, then in that case the acceleration will be negative. And if the graph, that is position time graph, is upward, then it is positive, means acceleration will be positive, means velocity goes on increasing. Now we will study about VT graph. Now students, this VT graph means it is velocity time graph, and here this velocity time graph is for acceleration. So now let us understand it properly. Now here in this graph you can see velocity along this line and time along horizontal line, that is along x-axis. Velocity is in meter per second and time is in second. Now you can see here this graph is a curved line from 0 second to 10 second, and in that case what is the velocity increased? So velocity increased from 0 to 24 meter per second in 0 to 10 second time. That means in this much time interval velocity increased from 0 to 24. So in that case we can find the acceleration. And how we can find the acceleration? So once again we know that acceleration is change in velocity with respect to time, that is a bar, that is average acceleration, is delta v upon delta t. And what is delta v? It is final velocity minus initial. And what is delta t? It is final time minus initial. So now what is this final time minus initial from this much graph? So it is 10 minus 0, so we will get it as 10. So difference of time is 10. And what is difference in the velocity for this much time? It is final velocity minus initial. So 24 minus 0 is 24, and so 24 divided by 10, you will get 2.4. So acceleration, that is average acceleration during time interval 0 to 10 second, is obtained to be 2.4 meter per second. Similarly, what is the acceleration from time t is equal to 10 second to time t is equal to 18 second? That is for this much part. So students, as we know that if it was a position time graph, then the slope of the line will give us information of velocity, but here it is a velocity time graph, and so the slope will give us the information of acceleration. And so here in this first case, when we obtain this difference, that is difference of velocities, that is vertical line because it shows velocity, and horizontal shows the difference of time. So when we take the slope, that is this part upon this part, then we get the acceleration. And here it was a curved line, so every time the acceleration is not constant, And so what we took the average acceleration. But here from time t is equal to 10 second to 18 second, the graph is horizontal line, you can see here. And in that case horizontal line is there, so velocity do not change, it will remain 24 only from time t is equal to 10 to 18 second. So we get acceleration is equal to 0 because velocity is constant. So if we take the final velocity, then also it will be 24. If we take the initial velocity, then also it is 24. And so if we put that values, final and initial, then their difference will be 0 because both are 24. So 24 minus 24, so difference of velocity will be 0, and 0 upon anything will be 0. And so we get the acceleration is equal to 0. So if the velocity is constant, acceleration is 0. Then now last part. In last part, from the graph onwards, we can say that here the graph is downward, straight line downward. First we will see that it is a straight line, means acceleration is constant. In velocity time graph, straight line is there, then it shows that the acceleration is constant, but it is downward, and so the acceleration will be negative. So now let us find this acceleration. Now here from time t is equal to 18 second to time t is equal to 20 second, what is difference of time? Final time is 20, initial is 18, so 20 minus 18 is 2. So here this difference of the time is 2. Now let us take the difference of velocity. What is final time here? Final time is 20. So at that time, for this point, the velocity becomes 0. So here final velocity is 0 minus, say this is final velocity, then minus, so I have kept here minus initial velocity. At time t is equal to 18 second, the initial velocity is 24. So 0 minus 24, and difference of this time is 2. So 24 by 2 is 12, but minus 12. So the acceleration is minus 12. So students, I hope the velocity time graph for acceleration is clear to you. Now about acceleration time graph. In acceleration time graph, you can see here from time t is equal to 0 to time t is equal to 10 second, even acceleration changes, means even acceleration also increases linearly. Then from time t is equal to 10 second to time t is equal to 18 second, it is constant, even acceleration do not change. And from time t is equal to 18 second to time t is equal to 20 second, you can see once again it is horizontal line here. That means acceleration is constant only, but it is negative. So students, this graph for acceleration time is same only as this. Both the graph represents same thing, same situation, but this is for velocity time graph and here it is acceleration time graph. So I hope you understood this also. As I said here that velocity is constant, and so acceleration is 0 for this much part 10 to 18 second. And so here also it is same thing, you can see from here to here this line is along this 0 path, so it is 0. and you can see this last part from t is equal to 18 to 20 second, it is straight line, means acceleration is constant but negative. And how much we obtain that acceleration? We obtain that as -12 constant. And so here also from 18 to 20, it is horizontal line on a graph, and that represents -12. So this -12 is acceleration, which is constant. And for this first part, it is curved line, means even acceleration increases, means changes. So from 0 to 10 second, here it shows this part. So I hope the thing is clear to you. So now let us move to next part. Now it is velocity time graphs which represent constant acceleration. VT graph for constant acceleration. Students, earlier we have seen the similar type of situation, but that was position time graph, and that was a straight line. Once again I'll show you the same thing. You can see, students, here when there was a position time graph and it is a straight line, what does it means? It means the velocity is constant. You can see here, position time graph will give you information of velocity. So straight line means velocity is constant, but it will be positive because the slope is upward. Position time graph, again it will give you velocity only, but it is downward slope, so velocity will be negative. And position time graph, horizontal line, again it is a straight only, so velocity is constant but 0. So always remember, students, position time graph gives information of velocity, means its slope will give us velocity. So here it is the velocity time graph, and its slope will give you information of acceleration. And here the straight line, here also straight line, here also straight line. So in all these three situations given in this three graph, it is a straight line. And if it is a straight line, means acceleration is constant, but here the slope is upward in first graph, and so acceleration will be positive. If the slope is downward, then acceleration is negative. And if there is no slope, means horizontal line, then acceleration is 0. So students, remember these things. And now, what does the area under VT graph means? What does the area of velocity time graph gives us? So it gives us displacement. Students, remember, the slope of the graph will give us acceleration, but under this much curve, that is this graph, area with time will give us displacement. That means area of this triangle OAB will give you displacement x. So here also, for this velocity time graph, this is the line which shows the graph. Now under the timeline, this is the timeline, this much area is covered. So area of triangle OAB is half of AB into OB. So students, half of base into altitude will give us area of this triangle OAB. But what is AB? AB is nothing but final velocity minus initial. So V minus 0 is V, that is change in velocity. So delta V is written here. And what is BO? BO is nothing but final time minus initial time. So here final time is t minus initial is 0. So we can simply write t. But here it is difference in time. So delta t. But after that, this step, it is written that it is V and this is t. So half of velocity into time. So this will give us displacement. So now students, always remember that velocity time graph, its slope will give us acceleration. Slope will give acceleration and area under the curve will give us displacement. So I hope students you understand about this velocity time graph. Now students, next topic is very much important. It is about kinematic equations, and these equations are used when the acceleration is uniform, means for constant accelerated motion. Students, these equations which we are going to now obtain or derive will be used in 11th standard in most of the chapters, also in 12th standard, also in higher studies. Now students, if velocity is constant, then we use a simple formula. Velocity is distance or displacement upon time. Simple formula generally we use for the velocity. But when the velocity is not constant, means there is an acceleration, and if the acceleration is constant, in that case this formula is not used to find the velocity. So for such cases kinematic equations are used. So here the method to obtain the kinematic equation is given. This method is called the graphical method to obtain the kinematic equation. And here this graph is for velocity versus time. And here this kinematic equation will relate these variables. There will be x, there will be t, there will be v naught means initial velocity, there will be v that is final velocity, and there will be a that is acceleration. So displacement, time, initial velocity, final velocity and acceleration. The relation between this variable is a kinematic equation. Now let us start with this graph. Here you can see at time t is equal to 0, the graph is starting from this point A and it is a straight line, means acceleration is constant. Now at time t is equal to 0, the velocity will be initial velocity, which is v naught, and at time t this point B represents final velocity. And so from the graph it is clear that during time interval 0 to t, that is this much, the change in velocity will be final velocity minus initial. So that is v minus v naught. You can see this much distance is nothing but is change in velocity. And here this is 0 and this is v naught. So this much part is v naught minus 0 means it is v naught. So this is v naught. Now students, we know that if we'll find the area under this graph, means for this graph AB line, area under this will give us information of displacement that I told you earlier. What does the area of velocity time graph give us? So that will give us displacement. So here also what we'll do? We'll do find the area. Also, what does the slope of AB will give us? The slope of AB will give us acceleration, and so we will also find the acceleration. So let us start with the simple thing, that is acceleration from the slope of AB. Now slope of AB means it is this triangle. So vertical upon this horizontal. We know that if we want to find the slope of this line, then it will be BC upon AC. But what is BC? It is V minus V naught. And what is this AC? It is this. This much length is equal to this length, and that is T. So calculation is like this. The slope of line AB will give us acceleration, and A is equal to BC upon AC. But BC is V minus V naught and AC is T minus T naught. You can see here BC is V minus V naught. Why? Because final velocity minus initial, and AC, this is final time minus initial time, that is T. So it is this. Now here remained is T only, because T minus 0 is T, and if we multiply this T here on left side, that will become AT. So what is remained here? V minus V naught. Now make the subject V. So we will bring this minus V naught towards left side, so it will become positive. So V is equal to V naught plus AT. I hope you understood this. Simply make the subject V. So it is V here. And what is remain on next side? On other side it will be V naught plus AT. So this is the first kinematic equation. This is final velocity. This is initial velocity. This is acceleration and time. So from the slope we obtained this equation. Now area. Area will give us displacement. So here also area under the curve of VT graph gives us displacement. So how much area is there for this? So it is clear that under this line AB, if we'll stretch these vertical lines, then this much area is covered. We have to reach from B to this time T and from A to this time, that is 0 time. So whole this region is to be considered. But we know that this region, that is O, B, D, O and A, this much region is made up of a triangle also and a rectangle also. Which triangle? Triangle ABC and rectangle ACDO. So we'll find the area of triangle. area of rectangle, and we will add both. So we'll get the total area. So let us do here mathematical steps. Displacement is area of OABCD, but this region OABCD, that is whole region, is nothing but it is triangle plus rectangle. Now area of triangle, that is OBC. Achha. Students, here it is a printing mistake. In place of OBC, it should be ABC. So triangle ABC, and we know that for any triangle it is half of base into altitude. Base is AC and altitude is BC. So area of triangle ABC is half of AC into BC, and area of this rectangle ACDO will be length into breadth, that is OD into DC. OD into DC will give you area of this. So same thing I have done here, only there is correction here, nothing else. Now area of triangle ABC is half of BC into AC plus area of rectangle CD into OD. Students, when you do this calculation or mathematical part, at least take a rough notebook and draw that figure which I have drawn, so that you can easily make out what I am doing here. So figure should be in front of you to understand this. Now what is BC? It is V minus V naught. And what is AC? It is T. So BC into AC is this into this, and half is as it is. You can see this BC, this much BC is V minus V naught, and AC, this much part is nothing but it is this only, time T. So I have done here same only. What is CD? It is V naught. What is OD? That is T only. CD into OD. I will show you here also. CD, this, that is V naught, and OD is T, and so it is V naught T. Now students, here next is simple mathematics. You can see V naught T as it is, X on left side as it is. But what is this V minus V naught? So from that equation number 1, you can see here it is V minus V naught, that is 80. So from equation 1 we will write 80 in place of V minus V naught. So in place of V minus V naught we have simply written A into T, but already one T is there. So T into T is T square. So AT square and half as it is. So we got a second important kinematic equation. X is equal to V naught T plus half AT square. So second important kinematic equation. Now from equation number 2, means this equation. So this is equation number 2. In this equation, open this bracket. If you open this bracket, you will find this half into V into T. First term will be half V T. then second term will be minus half v naught t, minus half v naught t, and this last term plus v naught t. So here you can see these two are the like terms, and half, and this is 1, so 1 minus half will remain half. In short, if we will solve these two, take v naught t common in both. So if v naught t is common, what will remain in bracket? Here it will be minus 1 by 2, and here in second term plus 1. So 1 and minus 1 by 2, what will remain? 1 by 2. For this it will be 1 by 2. So 1 by 2 v naught t, that is half v naught t. So students, what remained for this? Half vt was there, and after that simplification we got one more half v naught t. Now what is common in both this term? You can see 1 by 2 here also, 1 by 2 here. T is here as well as here. So you can say that half into t is common. What is remained here? V, and here v naught. So v plus v naught. So you can say that it is v plus v naught upon 2 into t, that is x. So students, I hope you can easily simplify this equation to get this equation. X is equal to v plus v naught upon 2 into t. So let us give this equation number 3. And now, as a is constant, so v plus v naught by 2 is nothing but it is average velocity. Students, this term, initial velocity plus final velocity by 2 gives the average velocity, because the graph is straight line, and if it is a straight line, then final velocity minus initial velocity by 2 will give you average velocity, and so the symbol is v bar. So here for this we have used v bar into t as it is, and here x as it is. Now from equation number 1, if we make subject t, we will get this equation. From equation number 1, make the subject t. You can see here this is equation number 1. If we make this subject t, a will be towards right hand side. So we'll get v minus v naught upon a. So t is equal to v minus v naught upon a. Now in this equation, in equation number 3, this equation, put this t as v minus v naught by a. So you will get x is equal to this term, and this is the value of t. Now students, again it is simple mathematics. We know that in mathematics, if it is v plus v naught into v minus v naught, then it is v square minus v naught square. We have used this mathematics, that if it is a minus b into a plus b, then it will be a square minus b square. So it is same here. You can see here it is plus in between, and here it is minus, and there is multiplication. So you will get this term upon 2 into a. It is here. Now bring this to a on the left side. So already x is here. So x into 2a, that is 2x. What is remained on right hand side? It is v square minus v naught square. So this is the third equation. So students, these are the three kinematic equations. If in future you are not able to remember this process of obtaining kinematic equation, then it's okay, but it is required for you to remember all this equation, this equation number 3, then this equation number 2, and this equation number 1. So all these three equations are widely used. So I hope you understand this process. In our next lecture we will study about the same equations, but its derivation is by different method. So students, write it, have a practice, do paperwork for this, and if you are not able to understand any step, any mathematical step, then you can ask me.